campers, welcome back to SQL Summer Camp, and specifically the Advanced SQL portion of Summer Camp, and even more specifically the one where we talk about analytic functions, aka window functions, which I personally have heard them called window functions more than analytic functions, but that's just me, and that sounds great. So I'm going to take this out so you guys don't get a little bit of an echo. So, analytic functions. One of the questions that I have gotten a couple of times during this camp is like, hey, I'm noticing that we're doing some things in SQL that we could be doing in, pandas or in R using data frames or data tables or different, methods of doing the same thing, but in a different language. Why would you want to use SQL? So the biggest reason specifically for analytic functions and related things why you would want to use SQL over R or Python is because it can be much, much faster. And I don't know all of the reasons why. That's sort of the part of computer science that I kind of fall asleep during. I find it less... I don't know, it's just not as big of a part of my intellectual background, if you will. But I linked in the email, if you got it, a really nice case study of someone, and I will say he wasn't using, I believe it actually wasn't a relational database, I think it was Postgres, so it was more of a tree structure database, but got almost a 15 times speed up by moving the same data processing pipeline from Python to SQL. So it can be a big speed up. James says, what year were analytic window functions introduced to SQL? I have no idea. That's a good question. If someone knows, please feel free to pop that in the chat. A while ago, if I had to guess, I'd say in like the 70s. Just complete wild guess. Okay, so let's hop into it. The notebooks that we're going to be looking at today, so you got the links in the emails if you signed up for the emails, but you can also find them by going to kaggle.com/learn/overview. And then for me, the Advanced SQL course is up here because I've already started it, but if you haven't, it's all the way down here at the bottom. Yesterday we did the joins and unions notebook, and today we're doing the analytic functions, and you can see I have a check mark here because I have already opened it on this account. So what are analytic functions or windowing functions? So you might remember from and I am going to cover up the chat because otherwise I'm going to, hi everybody, otherwise I'm going to get distracted by questions and I'm going to spend the whole time answering questions instead of going through the material, and I know this about myself, so I've covered it, I can't see it, I'll check back in when we're done going through the notebook. I'm intentionally ignoring you so I stay on track. So if you remember, in the first part of the SQL course, we learned about group by, and we learned how to apply functions over groups. So I think we talked about sum, we talked about average, we might have talked about minimum and maximum. And what that does is when you do group by, just as a refresher, because this is very similar, when you do group by, you take your table, you pick one or more columns, you treat every row that has the same value in that column as part of the same group, and then you apply the function to everybody in that group. So in our pets example that we've been talking about, if we wanted to find out the average age of every species, we could take the pets table, we could group by, species, so like rabbit, dog, cat, hedgehog, and then we could take the average of the age column from within that. So the difference between aggregate functions and analytic functions is that aggregate functions compress the whole group. So if I wanted to instead know how long different I'm trying to think of a good example. I should have thought of this previously. I did actually come up with some, and then I didn't write them down. So let's say that you have information about vet visits and you want to figure out how often you are going to see a animal of a specific type. So maybe you're trying to figure out if you should hire another vet for your practice, and you're like, oh, do we want a bird specialist? How often do we see birds? Or how long is it between when we see birds? So what an analytic function would let you do is it would let you group all of your vet visits by species, assuming that's information that you have. I'm assuming that it would be for a vet practice. And then within those species, maybe you look at the dates, you order all the dates, and then you look at the number of days between each date when you see an animal, right, from the same species. So maybe you see, a cat, you see 3 cats a day. So maybe you'd want to do it in hours instead of days. So it's like there's 2 hours between the first cat and the second cat, and then from the second cat to the third cat, there's like 4 hours, and then from the third cat to the fifth cat, there's, let's say a week. There's just like, you didn't get cats for a while. And then for hedgehogs, from the first hedgehog to the second hedgehog, it was 4 weeks. From the second hedgehog to the third hedgehog, it was 6 weeks. And then you could, once you had the information on how long it's been, then you could do your averages and your plotting, whatever else you wanted to do. But you have to make a lot of comparisons between rows that are right next to each other. And that's just much faster in SQL, and particularly in BigQuery, which is particularly well optimized to be fast. And other services for SQL are also well optimized, and I encourage you to research them if you're curious. But of the ones that I've used, BigQuery in particular is the fastest. I haven't used that many, like 3. Okay, so let's look at the syntax. So windowing functions do have a lot of parts to them, which is why we're doing them as a whole day, and you also hear them called analytic functions. So some of the parts, and I'm going to open this in a new tab. I think I can make it bigger. Yeah, there we go. I'm covering it. There you go. Now you can see the whole query at the same time. So we write it sort of similarly to how we would write a common table expression almost. So that's where we use as to create a new table that we can then refer to later. So we're going to select everything from this new table that we create that has the output of the windowing functions in it. And we are going to get all our information from this new data set we haven't seen before called BigQuery Public Data. So that's the project. If you're working on your own account, your project name will be different. Runners, which is the data set, and then train time, which is the table. So what we're doing here is we are first deciding what we're going to group by. So remember when I was talking about all my vet examples, we were grouping by species and we were looking at all the animals from the same species together. Here we are going to partition by ID, and each of these is a different runner. So we're interested in tracking specific runners over time. And then within each of those partitions, so you can imagine that we have our big table, and then after we group by, you can imagine, I don't think this is actually what happens, that you're creating a set of new tables, one for each group. That's not what actually happens, but it might help you to visualize it. And then each of those are unordered. And because aggregate functions are applied over rows based on the order that the rows appear in, you're going to want to order them in some way, probably based on something. And here we are ordering them based on date. So we've taken all of whoever ID 1 is, all of whoever ID 2 is, and then within each of those tables, we're sorting by date, right? So even if, I'm trying to come up with an example where if you did your sorting before your grouping, you'd get different results. Well, if you come up with one, share it in the chat, and we can look at it later. Yeah, I think that would only occur for things like distinct. You can imagine that. And so once you have your different tables that we're imagining for each of our groups, and they are sorted, we're going to say how we want to apply our specific function. And this particular syntax is, I know it looks like it's just written in English. I mean, it is written in English. Most programming languages are based on English. you have a couple of different options. The basic idea, and this is just the, can I move this over so it's not behind me? I can. It's still a little bit behind me, sorry about that. So this is talking about the order by. So this syntax here is called the window frame clause. And this is how it's sort of structured in BigQuery specifically. And I think this is one of those things where there's slight differences between different versions of SQL. And the general way that you structure this part of the query is you say the rows between, so what you're looking at, and then the first row that you would look at every time you're trying to apply your function, and then the last row that you would look at every time you're trying to apply your function. So here we're looking at one row before the current row and also the current row. So we're looking at two rows at a time. And what we're doing over all of those rows is we are taking the average of the time column. So just to sort of go over the operations we're doing again, we're grouping, we're ordering. Within each group, we are looking at the row before the current row and the current row, and then we are applying this average over the time column. So there's kind of a lot going on. I know there's a lot of words here, but that's the idea. That's what it's doing. And then once we have that output, we are going to return everything from our query. So just a little bit of extra information on the window frame clause. There are lots of different ways that you can, there are lots of different possible ways that you can sort of group your rows depending on what specifically you wanted to know. So you can imagine if you had information daily and you wanted to know the running weekly average, you might say rows between current row and, 7 preceding, 6 preceding, because you also have to count your current one, 6 preceding, in order to calculate the average over those, and then you'd have the average for the previous week. So that would be a way that you could do smoothing, for example. And if you're interested in all of the possible things that you can do, I would point you towards the BigQuery documentation, because that'll walk you through it. Something else, just like an FYI, if you don't say what the last row is, then it will assume that the last row is your current row. So it'll always default to basically appending this and current row to the end. So you can leave it off if you want. I would honestly recommend keeping it just for readability. But if you see queries like this, that's what the idea is. All right, so a little visual representation of what I was talking about. And actually, I could have been looking at this instead of using my hands, but oh well. Here we have our data set. We are going to partition it based on ID. So we have sort of two mini tables kind of, and then we are going to sort each table. So we're going to order by date, this date row, ID here is this row column, date here is this column, time here is this column. So these pieces of information are all coming from the data set, and they'll be different depending on your particular data set that you're working with, but the partition by, order by, average, and then this part are all going to be, that's all SQL syntax, so that will be the same every time. I don't know if that's helpful. That was something that really confused me when I first started learning SQL, especially because sometimes I'd look at queries where people weren't really good about making the SQL syntax uppercase and the sort of like table variable names lowercase, and it took me a while to figure that out, so I'm saying it out loud in case it's helpful. And then this is, we're going to take the average between one row preceding and the current row. So you will notice, if you look here at the average time for this first row in the first group, the time for the current day, or this day, was 30. There is no previous row, so it's just ignored, and we just get the average of the current row, right? So it's not 15. We don't sort of like guess that it was 0. We just ignore it completely. And then this second row here with the average time, is it behind my head? Let me open it in a new tab so it's a little bit bigger. This Nope, now it's extremely behind my head. There we go. This is fine. So this row here is the average of 30, the row preceding, and 26, the current row. This row is the average of 26, the preceding row, and 22, the current row. And then in the second group, because we only look within the specific partition that we're looking at, there are no previous rows in this partition. So the average that we're given is the previous row, there aren't any, and the current row, so it's 28. Again, instead of 14, we don't guess that if it doesn't exist, it's 0. Sorry for the shenanigans. So that's the general idea of how window functions work. And let's work through a couple of examples. Like with, the aggregate functions that we worked with previously, there are other things that you can do besides average. I think the two that I use the most often are average and sum, because I want to see a cumulative sum over time, and then also I want to have a moving average. So I think those are the two that I use most often in my work, but your mileage may vary. So some examples: minimum, maximum, min, max. The average or the sum returns the average or the sum, and then count, which returns the number of rows. So if you wanted to know the count of every what am I looking for? So if you did a partition function, if instead of average here, we used count, for this one we'd get 1 because there's no preceding row, and there is a current row. So 1, here we get 2, here we get 2, here we get 1, here we get 2, here we get 2. So maybe not always super useful. Maybe you'd want to use group by instead of a windowing function if you were looking for count, but you could use it with a windowing function. Some other helpful functions that you'll see used. So this is the first value or the last value in the input. So if you wanted to do something like if you wanted to look at year-over-year growth or month-over-month growth, and you were maybe looking at a couple different parts of your site, you could have all of the metric that you're interested in and the part of your site, and then you could partition by the part of the site, and then for each row, you could look at the first value from the 30, 31 days previously, or 365 days previously, unless it was a leap year. So you had a good idea of the change in that time frame. Lead or lag returns the value from the subsequent or preceding row. And then we have some rows, some functions that also just are helpful for numbering things. So row number returns the order in which rows appear in the input. I think that's fairly self-explanatory. It's sort of similar to getting the index in Python using pandas. And then rank, all rows with the same value in the ordering column receive the same rank value, where the next row receives a rank value which increments by the number of rows in the previous rank value. So this is just like in sports if there's a tie. So the top two people are both first, and then the second person, the person who came in third, isn't second, they're third, because there are two people above them, even though those people both share the rank 1, if that makes sense. And so this could be helpful for identifying who bought the most widgets from your e-commerce company, and you can send them a nice plaque. You're our #1 customer, free pen, whatever it is that you're doing to try and encourage customer loyalty. All right, let's work through some examples. So you can get a little bit of a better idea at what I'm doing. And again, I'm just going to copy and paste here. Generally, we would encourage you to fork on Kaggle. Kaggle.com/kernels. There we go. New notebook. Yes, Python. Yes, notebook. Create. Isn't this nice? The like the fancy new notebook launcher. And the nice thing is, if you're trying to change the the language of your notebook or anything, you don't have to let's scooch it back. You don't have to relaunch your notebook every time you add something, which is a nice time saver. All right, and the particular data set that we're using is San Francisco bike trips. So San Fran SISCO bike. I'm gonna zoom out a little bit so I can. Ben Hamner. Oh, and this one is a BigQuery data set, so I think it's probably that one. So let's add this one. And we'll find out if we get an error. And again, if you'd forked, your data set would already be attached for you, so you wouldn't have to do all this bit. So fork. Oh no. Let's call this Analytic Functions Scratchpad. All right, so let's run this. And this is just setting up the client and letting us take a little peek at the data set. And we talked a lot about this during the first day of SQL Summer Camp, so if you are curious, you can go back and check it out there. And you can see that we get information about this bike share and the number of trips. So here we have the trip ID, the duration in seconds, the start date of the trip, the start station ID, the end date of the trip, the end station ID, the end station name and ID. So these are kind of short trips where people are going from one bike station back to the same bike station, so doing a little round trip. Scooch, 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 scooch. The number of the bike, the zip code, which is sometimes nil, interestingly. That must be, maybe it's the customer's zip code, and sometimes they haven't filled it out. And then whether it's a customer or, I guess, a different type of subscriber. Don't know what that would be. So that's the information that we have in our data set, and we're going to write some analytic functions over it. So let's copy and paste this one. I don't know why copying and pasting is genuinely hard for me in the mornings. Maybe it's because I haven't had much coffee. All right, so this is a big meaty query. Let's work through it and talk about all the parts and what they're doing. So the first thing we're doing is we're doing a common table expression here. So we're creating a new little table that we can refer to in the rest of our query called trips by day. And what we're doing is we are selecting the date from start date. So that was close to the beginning. Here we go. Start date right here. So we're getting the day of the year. Or the day and the year, sorry. And then we are counting all of the rows as number of trips. And because we are using an aggregate function, we have to make sure that we group by or also aggregate by everything else. And you can see trip date, we are grouping by here. So we're taking all of our dates, we are squishing all the same dates, all the rows from the same date together, we're counting them, and then that's what we're returning. And we are getting the data from BigQuery public data, that's the project, San Francisco is the data set, bike share trips is the table, the specific table, which is the same as bike share trips up here. And then we are also only looking at the year 2015, so we're narrowing our focus a little bit. Maybe we are trying to sort of keep track of things and we want to know the cumulative sum of bike trips. So maybe we're trying to see if there's a pattern, see if demand is increasing, or we've sort of reached a leveling off point, or it's dramatically decreasing, which would be not so great. We prefer not to see that probably if we're running a bike share. So we are going to use this windowing function. We're going to get everything from it once it's been returned. We are taking the sum of the number of trips in this windowing function, and we're doing this over. So we are not doing a partition here, right? We're not actually separating it into groups. So everything is going to be treated as if it's in the same group, which it is. And then for that whole big group, we are going to order by trip date. So we're taking our big table with all of the dates in 2015, assuming somebody rode a bike on each of those dates. And then we are ordering it by date. So first date to last date, following the flow of time. And then we are doing rows between unbounded preceding and current row. So unbounded preceding means we're looking at all of the previous rows in our partition, and because we only have one partition, we're looking at all of the previous rows in our data set and the current row. So we are looking from the start to the current row, and then we're taking the sum of everything above our current row, including our current row, and then that's going to be called cumulative trips. And then we are getting all of this information for this from this common table expression up here called trips by day. So we're creating this table, and then we're immediately running aggregate functions over it, and then we are getting the results back. So what we should expect to see based on this query, actually I'm going to let it run and then we can walk through it. What I should expect to see is the columns from trips by day, because that's what we're using our windowing functions over. So we should have trip date, number of trips, and then we created a new column here using this windowing function called cumulative trips. So we should have 3 columns, and sure enough we do. You'll notice that they're sorted, so it starts with January 1st, January 2nd, January 3rd, January 4th, etc. And it starts in 2015, which makes sense because we're only looking at things from 2015. And then we have the number of trips, so that was the number of trips taken on that day, and then the cumulative number of trips. So 181 plus 428 is 609, plus 283 is 892, plus 206 is 1098, and so on and so forth. So we can see that we have the number of trips divided by day, and then the total number of trips that have been taken so far in 2015. All right, and we got one more query here. Yeah, that is the last one. Let's double check in. I was pretty sure there was one more, but sometimes you make mistakes, and that's normal. Okay, one more query. Maybe we also want to track something like the mileage or the number of trips per bike. Maybe we're insuring our bikes. I don't know if you can get bike insurance. Let's imagine that you can get bike insurance and that our insurance company wants to know, hey, how much your bike's being ridden. So let's find out. First of all, we are going to do, so we're doing a couple of things. So we are selecting bike number. We are selecting the time of the start date as trip time. So we're creating a new column here and then aliasing it as trip time. We are applying a windowing function. We're applying a second windowing function, and then we're selecting start station ID and end station ID. Because remember that windowing functions create additional columns. So just looking at this, we should have 1, 2, 3. This whole big thing here is 3, 4. This whole big thing here is 4, 5, 6 output columns. All of the data that we're getting is from an existing table. So instead of creating a common table expression, we're just looking at an existing table here called BigQuery Public Data. That's the project. San Francisco, that's the data set. Bike share trips, that's the table. And I know that I say that every time, but it's helpful. It's sort of like a folder, file folder structure on your computer. And then we are filtering, so we are only looking at trips that started on October 25th of 2015. So we're looking at a single day. So what are in these windowing functions? We've got the bike number, we've got the trip name. We are going to find the first value of start station ID, right? So we're looking at the station that it started at, basically. And we are going to do that over this windowing function. Here we are partitioning, so we're partitioning by the bike number, so that's the ID number of the bike. Each bike has a unique number. So however many bikes we have, we sort of separate them out. We order all of those tables by the start date. And And then we are going to get the rows between unbounded following, preceding, and unbounded following. So we're looking at all of the rows in that partition, and we are getting the first value of the station start ID when ordering by start date. So we're looking at the very earliest date, and then we're getting the value of start station ID at that time. And then we're calling that whole thing that we've gotten back first station ID. We are also getting the last station ID. So we're getting the last value of end station ID, and then we are partitioning again by bike number. We're ordering again by start date. We are again looking at all rows in the partition, but instead of looking at the very first value of start ID, we're looking at the very last value of end station ID. Sorry, start station ID. So this is making sure that we're seeing, we're ignoring all of the start stations and end stations for trips that were not the first trip on the day when the day is 2015 10/25. So let's run this guy. And sure enough, we have 1, 2, 3, 4, 5, 6 columns. Wow. This one with numbers is one that Panda makes up. You can ignore that one. You can see that we have the bike numbers, the trip time for the specific trip, the ID of the first station, the ID of the last station, and then the ID of the first station and the last station. So let's see, first station and last station are the ones where the bike started at and ended at over the entire date range. And then start station and end station are the IDs for the stations that the bike moved through on each of its individual trips, right? So we can see we have bike number 25 here twice. It started at station 77. It ended at station 51 over the whole day, and we can see it took 2 trips, so one from 77 to 60 and one from 60 to 51. So it makes sense that we would see the bike twice because it took 2 trips, and it also makes sense that the first and last station ID are going to remain the same both times we see the bike, because we were looking for the very first station ID and the very last station ID. That makes sense. Okay, I know there's a lot to there's a lot of syntax around common table expressions, but they are, once you sort of like understand what's going on and you're like, oh, okay, this makes sense, I think they're very nice and handy and big time savers. Much faster to do this in SQL than in pandas or R. Certainly with base pandas and base R, data table might be on par, but don't quote me on that. That sounds like a good question for a blog post if anyone's looking for a blog post to write. All right, now I'm going to uncover your comments and look at the comments that you guys have left into your questions. All right, and I'm only 3 minutes behind schedule, so that's not so bad. Raymond says, are analytic functions supported in other SQL systems, SQLite specifically? Oh, yes, that was an easy one. Thank you. Sunny says no. It looks like SQLite tutorial.net has a tutorial for it, so. All right. Count is useful when there are nulls in a column. Yes. Yeah, I guess that would be a good place to use count. Yeah. Good point. Quarky. Count is very useful. Row number, Abhishek says, row number is extremely useful for moving duplicates when there are duplicate primary keys. Helpful. Dragon says, can I still join the SQL summer camp? I just found out about it this week. Is it still possible? Yeah, absolutely. So we have the stream today, we have the stream tomorrow, and if you're looking for the certificate, you need to do all of the Intro to SQL, the Advanced SQL courses on Learn, and then also the BigQuery Machine Learning tutorial that should be linked in the SQL Summer Camp playlist here on YouTube is what that platform is called. All right. Robbie says data.table is faster than pandas. Oh yeah, for sure. It's faster than pandas. I just don't know if it's faster than SQL. my feeling is that it can. I don't actually know. I don't have a strong intuition here. My guess is that a well-optimized data.table workflow is going to be faster than a poorly optimized SQL workflow, but that's maybe not the fairest comparison. Jake said, how often in the real world do you use these functions versus just importing them into pandas and then manipulating it? I will be honest, I prefer, like, my preferred order of operations, like if I get to pick my tooling, specifically for manipulating tabular data, first I would pick R, second I'd pick SQL, third I'd pick pandas. So for me, I would definitely pick it over pandas. If you have a large data set and you're doing this routinely, SQL will save you processing time. So that's usually. Michael says, will there be other events like the SQL Summer Camp in the future? Maybe. This one seems to be going pretty well. We've done a fair number of different educational events, and I really want to do one on writing modular code and sort of like functions and packages, because I think that that's something that a lot of data scientists don't get explicit instruction in, and it's so useful. It's so useful, you guys. So maybe. Veil of mystery. Could you make videos about SQL, primary key, foreign key, unique key, etc.? We talk a little bit about it in the first video in this playlist, the Intro to SQL, Welcome to SQL Summer Camp. I forget what it's called. We talk about it a little bit, but this is pretty, what's the word I'm looking for? Experiential learning? I want you guys to be able to use the tool and sort of understand what the syntax is, but maybe not have a super deep understanding of all of the ins and outs of SQL, because that's like a whole nother career, y'all. That's an entire other job. And if you feel the call and you're like, I must be a DBA, go for it. Knock yourself out. But it's going to be a slightly different job than being a data scientist, which is fine. Lots of requests for the modular code. Noted. I'll stick that in my bun. And Anthony says, depends on the data, presumably for when you would use pandas over SQL. All right, let's head to the forums and answer some forum questions. Yeah, there we go. All right. Kay has a question on the analytics function exercise questions. I didn't include the one, and my query is correct. What is the purpose of including one in lag, time, and trip and timestamp one? I believe, so this is sort of like how far to look back. I believe the default is one, and I would include it over not including it. I mean, mainly it's a stylistic question, right? So if you guys have read the Tao of Python, the Zen of Python, there's actually a way to get it in, it's in base Python. There's a specific command, and then I have to run it. There we go, the Zen of Python. So these are sort of like a set of programming principles that you can choose to guide your coding. And one of them is, and that I quote all the time, explicit is better than implicit. So if you have the option of including something that is the default value or not including it, even if the command would run the same, I would include it. And for me in particular, it's because other people look at and use my code, right? So if I write a query, and this is super common, at least in my work experience, I'll write a query, I'll send it to somebody, maybe we'll do a code review on it and be like, hey, is this getting what I think I'm getting? And if I'm taking all sorts of, shortcuts and tricks and making my code super duper compact, it's harder to read and it's harder to understand what's going on in the query. So the code review is harder, and I'll probably get some comments on readability. And also, just in terms of helping someone who is new be able to understand the code and what's going on, just like including those default variables is helpful. So that's my personal personal stance on the matter. I also, if you guys have watched me live code, you know I tend to comment pretty liberally. So, yeah. And people are telling me that it's import this. Thank you. There's a bit of a lag between the stream. I'm not ignoring you. All right. Jagjit says, do data scientists have to have knowledge about an ETL? So ETL stands for execute, transform, load. Nope. Extract, transform, load. So basically you have data in one place, you want to get it into a different place, change what it looks like, and then send it somewhere else. That's basically what ETL means. In order to get a job. Generally, job descriptions want previous data warehousing experience. I saw this many times. Do you need it? It's really helpful once you get the job, if you can sort of hit the ground running. At least in the US, the job qualifications that people put in job postings are like wish lists. If you can't do all of the things, I would still apply. Because I mean, what's the worst that can do is they can say no, and that's fine, and you've just wasted a little bit of time. And if you're applying for jobs, you're probably casting a pretty wide net anyway, or at least I was. I would say it's good to know. Do you need to be like do you need to be a DBA to be a data scientist? No, I think it's reasonable to be like, I know something about it, I can make it work, it's not going to be the most elegant. I also have to know about the field of machine learning as a whole, and I have limited brain, so like, I can learn that, but that means that I'm not going to know about this new, this new architecture that people are using. Or like, I can learn that, but that means I'm not going to be able to do causal inference because I don't have time to study that. So I know it's a tricky question. If you're interested in more of a ML engineer or data engineering role, then I would definitely spend some more time learning ETL and like building little sample projects and being like, look what I made. If you're interested in more of a analytic-y data research position, I would not spend quite as much time. So that's my wisdom from my many year of experience. Okay, that's not fair. I've been in the field for a while now. Quarky says, if you meet 40% of the qualifications, apply. I think that's a good rule. Yeah. And lots of good advice in the chat. Really depends. Yeah. Okay. Let's head back to but that was a really good question. Okay. Let's vote. Let's head back to the forum, see what else we get. All right. People talking about the beginners competition. The deadline for completing the SQL exercises is this Friday, which is the 30th. And I didn't say a time because the time that I meant in my head was midnight anywhere on Earth, if you're familiar with that. So just like by Friday, you should be fine. I probably won't write the query until Monday, but I will make sure that if you finish it by Friday in any time zone, you should be good. And I will reply to that a little bit later. All right. Oh yeah, no, I did notice that. Oh, thanks for pointing it out. Yes, I did have the wrong subject line in the email. It should have been analytic functions. I had it in my draft, and then I don't know why I didn't change it. Thank you. I appreciate y'all watching out for me. Visual representations of SQL joins. Yeah. So this is very much like every SQL 101 course, you see something like this. So inner join, right join, left outer join, left inner join, full join. I don't know what this one is. I don't think have I ever wanted to do that? I guess, like I can think of hypothetical examples where you might want to do that, but I don't think I've ever actually needed to do that in my work. Maybe I'm wrong. I'll go through some of my old queries and see if that was right. All right, let's see. Other questions. Do you need Tableau knowledge to become a data scientist? If you want to work for a company where they only use Tableau, then yes. Tableau, fun fact, actually, it's like sort of close-ish to the office that I work from. Yeah, it's a nice visualization tool. I personally, because I have a lot of experience with Python and R, find it a little frustrating because I want like complete control and customization, and I don't have that. It's sort of like how, Apple and Microsoft used to be. Like, Apple computers just like did it for you, and that was their ethos. And Microsoft, like, you had to do a lot more things yourself, but you could also like futz with everything and make it just to your liking. I'd say that's the sort of difference that I have. But I know some people who absolutely love Tableau. You'll see some really gorgeous visualizations coming out of the tool. So yeah, I think they also have a free version, so you can just play around with it and see if you like it. All right. Robbie says, you need to chest press 200 kilograms to become a data scientist and like fight a shark. And yeah, I know it can sometimes feel like that. It's rough out there. If you're on the job market, keep going. I believe in you. Take care of yourself. Exercise. Like, go for walks. Make sure you drink enough water. Yeah. Yeah. Absolutely. Abhishek says, I love D3.js and Altair. Oh, Altair is very nice. I do not like I'm not a huge JavaScript fan. It's just so fiddly. I know I just said I liked messing with everything and having complete control. It's so fiddly, though. Ugh, I don't think I'd be a very good front-end engineer. All right. So that's a nice little visualization to share. So thank you for that. Ilona? Yana, maybe? If it's Spanish? Suggestion for the exercise. Maybe we can try to reduce the amount of training data. Oh, this is from the BigQuery machine learning exercise, which is literally what it says in the title. Yeah, definitely. So if you were part of this, if you did the BigQuery machine learning, you know that the sort of like final thing that you're doing is trying to predict how many people are going to use a bike share. And this person is suggesting looking at different years and different months and seeing if there's something there. No spoilers, but if you wanted to add some additional outside information and search for Austin bike share in about the time period that the problem is for, I think you would find it helpful. And that's, I don't know. I feel like the step that often gets left out of a lot of data science education is like step 0, which is like understand what's going on in the data and know about the general problem. And a lot of the a surprising amount of, maybe not a surprising amount, but a large number of people who win Kaggle competitions, of course, they're great at machine learning and model building and validation and everything like that. But also, generally, they're really good at feature engineering and understanding the data and learning more about it and, maybe talking to subject matter experts and using that to develop new features that really capture important information. So one of Anthony Goldblum's, he's a Kaggle CEO's favorite examples of all time is there was a competition where you wanted to guess the price that a car would sell for at an auction, and the winner engineered this feature just like, is the car a basic color or like a fancy color that you had to order special? And the cars that were fancy colors that you had to order special tended to sell for more at auction because they'd been taken better care of because they were bought by people who really liked cars. So yeah, always do your research. There's nothing wrong with that. That's a key part of the job. All right, questions. About D3, read Amelia Wattenberger. She explains D3 like you explain all stuff data science. Okay. Maybe that's my next project, is to just get over my distaste and start poking at JavaScript and make some pretty visualizations. All right. James said, Rachel, how did you make this video? You are in the bottom in front of a web page. So when I extend my arms, you can't see me because I'm out of the camera range. And then I have, you can't see it because it's chroma keyed. If I do my hands really fast, you can kind of see it. I have a green screen behind me that I set up. So yeah, I know I should keep my right there. I should keep my gestures into this box, but I get excited. Yusuke says, what's your best method to study SQL? I'm not being flippant, but the only reason that I learned SQL was because I had data that I had to get that was in SQL. And I very much, I think I built a database in grad school as part of a research project because I sort of wanted to learn more. And then once I sort of had learned a little bit about databases, I was like, great, I'm done with that. And it wasn't until I started working, and again, I needed the data, and it would be really impractical for every time I wanted to get a specific subset of data, I go bother somebody on the engineering team, especially because a lot of them are in Australia, and so by the time that I'm really ramping up in the afternoons, they are asleep. So learning SQL was necessary, and that's how I actually I don't want to say it was forced, but that was my motivation for learning how to write SQL queries. So my recommendation for you, and what has worked for me in the past, is to work on a project that you are genuinely excited about. Come up with something that you're like, yeah, that's what I want to do, that relies on SQL data. So we have a lot of the BigQuery data sets on Kaggle. Ooh. I should not put my T next to my mouse hand. So if you go to data sets, and then, do we actually have a BigQuery filter? We do have a BigQuery filter. So fancy. And here are the BigQuery data sets that we have on Kaggle. So hopefully one of these, you're like, okay, that's interesting. I could really build a project around that. Something that I've been meaning to do and still haven't done is to use the GitHub database, the GitHub repo database, to look at how people are handling the transition from Python 2 to Python 3. Python 3 is in its end of life this year. Excuse me, Python 3 is fine. Please use Python 3. Python 2 is in its end of life this year. So if you're using Python 2, it's not going to be, actively maintained going forward. So a lot of people are transitioning to Python 3, which is being actively maintained. And I think it would be really interesting to look at sort of pull requests around that. And I just haven't had time for it because I've been busy. But if any of you do that, please write a blog post and send me the link. I will happily retweet it. I want to find out. And also lots of recommendations for SQL Zoo, which I've definitely seen people talking about. Bruce says, are more advanced functions like FFT doable in BigQuery or any other SQL implementations? I'm assuming by FFT you mean fast Fourier transform? Almost certainly. Fourier transform SQL. Time series. Yeah. It looks like somebody's written the code on GitHub. Okay. Maybe don't copy and paste this code. So this is removing things from the database. And as someone who's not a DBA, I never use drop. Drop doesn't exist to me. I live in fear of accidentally deleting something. Yeah, this looks pretty straightforward. I don't know what flavor of SQL this is for. But yeah, absolutely, you can do that in SQL. People do some amazing things in SQL. People train neural networks in SQL. I don't know that I'd recommend that, but it's definitely possible. It's a Turing complete language. You can do what you want. At some point, right tool for the job, probably you're going to want to use something else. But yeah, it's possible. And Fernando says, I find that learning by example is a really great way to learn stuff. Yep, that's what I found as well. Abhishek says, I want a real data science job. Most of the time it's vanity hiring, at least in my country. Hard to get a job in another country. One thing that might be a possibility, especially if you have a strong portfolio, is working as a consultant and doing sort of independent work, and people have a problem and you come in and you work on the problem and then they pay you and that's the job. I do know a couple people who do that. I will say it tends to be, I mean, it's stressful, right? Any sort of freelancing is stressful. You're going to have, fat times and lean times, and yeah, but that is an option, especially because data science work you can generally do remote, unless it's super sensitive data that you have to physically be on the machine that has it. So that's one possibility. Again, can be very stressful, but if that sort of work and flexibility appeals to you, maybe an option for you. Oh. Nico Tuba says, how can I engage more in the Kaggle community? Good question. I mean, there's always a lot of activity around competitions. I personally am not super motivated by competitions. I like to go to data sets, search by new, and then see what people have recently uploaded, and then write kernels on them, and then leave a comment on the data set and like, hey, data set uploader, I wrote a kernel on it. I haven't done that in a while, but it was really fun when I was working on it, and I could just a lot of scientists were uploading data and had specific problems or data cleaning stuff, and so I got in there and played around a little bit. So that can be a fun way. Helping out on the forums, people always have lots and lots of questions. Woohoo! Getting started is a good place to. I double checked. Getting started can be a good place to answer. Find people who have questions and answering them. Also, questions and answers. People generally have questions waiting for answers. So that's a really nice way to get involved. And if you don't know, you can research it and look it up, and then you will know, and then you'll feel smart. So those are my suggestions in general. All right, we're getting close to the end. Nico says, excellent stream. Thank you. Thank you. Is there any opening in Kaggle for data analyst? We're not hiring right now, unfortunately. We'll post about it. So, actually, I don't know where we would post about it, because Kaggle is part of Google now, so you have to go through the Google hiring process, which is rough. Oh, it's rough. I got through it, but it was not a stress-free experience by any stretch of the imagination. Yeah. So we're not hiring right now, unfortunately, to answer your question. What is the benefit of getting a Kaggle job? Certificate is helpful to get a job. So the certificate we're doing for the SQL Summer Camp is actually the first certificate we've done. I don't know, it might help. I know that certification is much more important in other places than it is in the US. In the US, it's just sort of like, oh, that's nice. And I know that it's more valuable of a credential in other places, so I don't know yet. I hope this helps you get jobs. I hope everybody gets hired and has good, interesting work that improves the world. All right. Speaking of forums, let's do one more question. Has anyone added one? Another one from BQML. I'm gonna have to go through and talk to everybody. Here we go. From Union, which was yesterday, would someone will tell me that there's a difference between these queries? There are 194 entries that are different between the queries. Oh, I did answer this. But I think it is a good one to talk about. So there's two queries here. So one selects two rows and then gets columns, sorry, because Union works on columns. So selects one column, selects a second column, and does a union distinct. The other one selects one column, gets only the distinct values, selects the second column, gets only the distinct values, and then joins them all into a single column. Jake was wondering why he had more rows in this column than that column. And the reason is because if you do distinct before union, you'll get rid of repeated values in your data set that you've selected, but not in the total data set. So here we've gotten rid of all the repeated values in the single data set, but in the union of these two data sets, we have repeated values. And here we don't get rid of the repeated values in each of the data sets, but we do get rid of all of the repeated values when we do the union. So it's a little bit of like a mental model of order of operations. So hopefully helpful for you guys as well. questions. I couldn't get started with the BQML. You will need to add your BigQuery account, so that might potentially be part of it. So in the side panel here, it's this one down here, or when you create a new notebook under the Advanced Options menu that drops down at the bottom, you can add it there. And you also want to make sure that, I'm just talking about the most common 2 errors. I don't know that these are the ones you're running into. You also want to make sure to replace the project name with your actual project name from your BigQuery account. Because if you use my project name, unless you have a project that has exactly the same name, it's going to look for it and be like, there's nothing there, error, nothing for you. So that's the 2 most common errors that people ran into in the BQML event. So, and if your error isn't one of those, post it in the forums, and I'll take a look today. All right, it is 10 a.m. for me. I'm gonna wrap it up. Thank you for joining, everybody. Next week, I was gonna say next week, tomorrow, next day. Clearly, I'm using a lag of 7, or lead of 7, I guess, because it was the future. Sorry, a little bit more coffee. What am I looking for? Courses. So tomorrow we are going to talk about nested and repeated data. So we've talked a little bit about how you would probably not use SQL specifically for data that isn't tabular, but actually you can secretly. So that's what we're going to talk about tomorrow. Again, secretly. Probably your whole database shouldn't be, documents with a tree structure, but some of it can be. We're going to talk about that. And then we'll do like a little sneaky stream on Friday as just like a bonus. To get the certificate, you only have to do the first 3 lessons. The 4th one is a little bonus lesson. All right, gonna wrap it up today. I'll be on the forums. I mean, not all day today, because I do need to like sleep and eat lunch and whatnot. And I will see you on Kaggle and maybe tomorrow for the live stream on nested and repeated data. So looking forward to that. Thanks for joining me, and I'll see you guys you campers, I guess, on Kaggle. Bye.